Okay, we have done this. So you can actually see the physical state is different if you see under the microscope. Okay, scanning electron microscope, you can see this molecule, and then what types of typical products and their punya functionality lah. So for each of the functionality, they will not be the same for each of the physical states. Okay. And then solidified fats, they exhibit polymorphism. Polymorphism ni relate to the referring to the crystalline form, the crystals. That means they can exist in several different crystalline form. Okay. So depending on the manner in which the molecule orient themselves in a solid state. So meaning that macam mana the solidified fat ni kan because of the reason yang ada cooling rate, ada temperature, ada holding time, holding temperature. So these are all will contribute to what type of crystal that will form in the food system lah. Okay. So depending on the manner in which the molecule orient themselves in the solid state. So this will confer what type of polymorphs kita panggil, what type of crystals or polymorphs that will form. So we call it alpha, beta prime, and beta. So this one is different molecular packing. Okay, dia punya shape tu we call it hexagonal, or rhombic and triclinic. Okay, this is the name that the scientific name lah for this the hexagonal or rhombic and triclinic. This one has been coined by people who studied fats and oil. So we have been using this term for many years. Okay. So in terms of thermodynamic stability, thermodynamic ni dia selalu nak dia punya energy yang paling rendah kan, paling rendah, so that thermodynamic punya hukum thermodynamic is always the lesser, the lower the energy, the more stable molecule is, right? Okay. So in terms of thermodynamic stability and melting point, they decrease in order of beta, beta prime, and also alpha. Okay. Okay. So this will be the most thermodynamically stable lah. Okay. As opposed to this beta, beta prime, and also alpha. Okay. Okay, kita tengok kat sini. Okay, this one is polymorph forms. I don't think you have this in your slides. I took it from one of the good reference in people who study, the scientists who study in University of Guelph, Canada. This one is from Professor Marangani. Professor Marangani is one of the famous scientists in the world who study fats and oil. Okay, all right. So this one is there's something is written here. Let's see. Liquid. Okay. So this is liquid. Okay, liquid ni depending on the formation of the crystal. Okay. This one is hexagonal. Hexagonal dia punya structure or dia punya crystal susunan, the packing of the alpha tu, kan, alpha crystal dia hexagonal macam ni. Dia is difficult to mention here, but you can actually see the shape of the hexagonal is like this lah. Dia macam a bit of hexagon, but under microscope dia macam mana nak cakap shape ni hexagon lah, it looks like a hexagon. Okay, but this one you can't really see the hexagon shape. Okay, but for this one is actually if you can see the difference between this black and this gray arrow. Okay, the black arrow is the endothermic transition, the gray arrow is the exothermic. Exothermic is mengeluarkan haba lah. Okay, so from the alpha, beta prime and beta, dia adalah exothermic punya ni. Sekejap apa jadi macam ni. Okay, you can still see my slide kan? Okay, So this is hexagonal. This is the orthombic tadi, okay, orthombic, and this is the triclinic. Dia punya location yang ni, dia punya susunan tu. Okay, you can actually see orthombic macam ni, triclinic dia macam ni. The fatty acid punya structure tu. Okay, the fatty acid structure is like this. Okay, and then polymorph characteristic for alpha, okay, it is unstable, lifetime, typically short, exists primarily during processing. Okay, and then for the beta prime is metastable, lifetime, range from short to infinity. Okay, and then for the beta, it is more stable, lifetime and infinity. So this is the polymorph forms of fat crystal, including the possible polymorph transition. Dia sebenarnya boleh tukar-tukar. Dia boleh tukar from alpha to beta prime to beta, or beta prime to alpha. Okay, so these including the possible polymorph transition, subcell packaging structure, stability characteristic, anti-ag stacking conformation. Dia macam mana dia stack of the molecule kat on the fat crystals too, that will confer what type of crystals that you will have lah. Okay, so you can just remember this one, hexagonal, orthombic, and also triclinic, right? Mungkin kat sini boleh tengok lagi macam ni. Okay, and also the susunan tu, okay, susunan the alpha crystal, beta prime crystal dengan beta crystal, dia macam ni lah. Okay, alpha crystal, it is more random. The way the crystal is being packed in the molecule, they are more random. And then for beta prime dia more structured. But one is going this way, another one is going that way. So actually dia macam ni lah. Okay, but here you can see it more clearly. Okay, for beta crystals, it is more parallel. Dia tak ada yang perpendicular tu. More parallel. Okay, so this one, the beta crystal, the beta shape is more stable as opposed to the alpha crystal. Okay, so the more stable and then the least stable. So kalau dia more stable, it will have the highest melting point. Okay, some of the fat that occur, sama ada dia highest melting point, more stable, this term of beta crystal. Some of it in beta prime, some of it in alpha, some of it is a mixture of these three. Tengok macam mana dia punya conformation of the beta, of the crystals lah. Okay, the greater stability derived from greater packing density, because of the packing density. The one yang dia pack very closely to one another, the one yang disusun as parallel as the beta crystal ni, that one is more dense of fatty acid group and favored by homogeneity. Homogeneity ni meaning there is no mixture between beta prime and alpha. Dia homogeneous, satu, one type of crystals. Okay, so this will give the greatest stability lah. Okay, this one is not too clear, but somehow it looks like this lah in a different drawing. Okay, okay, this one is alpha, this one is beta, this one is the beta prime, this one is beta. Crystal form affect physical chemical properties of fat and final product properties. Okay, this one pun sama lah. Ada banyak there are actually many factors that affect physical chemical properties of fats and final product. Nanti normally for bachelor student, they will study this type of physical chemical properties ni in terms of treatment, in terms of what type of technology that, I think for your case, you will use the technology for engineering, then you will study how this technology will have an effect to the food system. So part of the analysis that you need to do are the physical chemical test. Okay, physical chemical test sebab kita nak tengok sama ada the one that your new technology or your suggestion, what you do to the machines, for example, will have what type of changes it will give to the food system. Okay, I had this one PhD student by Prof. professor from your department, Prof. Yus, Yus Aniza, we had this one project that we did a few years ago, and the student already graduate and master student, and now he's doing his PhD in, I think, in Korea. Okay, one of the strong group in in studying the physical chemical properties of food system. Okay, so during Johnson, nama dia, he's from Nigeria. Okay, during his study for master's degree, so he did this two treatment. One is ultrasound. Okay, one is using this machine. Okay, that to study how does this ultrasound will have an effect to the tomatoes. Okay, so lepas dia guna, after he used this machine that use the ultrasound, okay, single ultrasound, and then another one is the I can't remember what's the treatment that he used. Okay, so treatment 1, treatment 2. So he study whether this combination of these two treatment will have an effect or to the physical properties of the tomato. So dia kaji dia punya the analysis. He did the lycopene. We know that lycopene is a very strong antioxidant, a good antioxidant in tomatoes, kan? The one that gives you the color of tomato is the lycopene, the pigment, lycopene. He also study the shelf life. Okay, shelf life. Lepas tu kena buat test lah sama ada whether the tomatoes can have a longer shelf life. Okay, then he did antioxidant analysis, proximate analysis. So meaning that when you want to suggest a technology, okay, you have to do the analysis part. All right. So back to this fat analysis. So maybe you will do this in your FYP project. Okay, FYP project for the analysis of fat after you give the treatment by modifying your machines, or you give new treatments, for example, kan? Kita study sama ada effect tak of that machines new technology to the properties of the food. Okay. So mungkin you akan buat analisis ni nanti. Okay, so TAG often crystallize in alpha form initially. So alpha form is the initial crystal form. Okay, the crystal form of fat can transform from lower melting point to higher melting point crystals. So this rate of transformation and the extent to which they proceed actually are governed by the factors there. Okay, molecular composition and configuration of the fat. That one is number 1. Number 2 is the crystallization condition. And then the temperature and duration of storage. Actually, bila kita store kita punya food tu at certain temperature and how long the temperature, dia boleh tukar the fat. We're talking about fat based punya food lah, macam chocolate ke butter, you know, that one is like fat based product, kan? Margarine. So dia boleh tukar from at which temperature and duration of storage. So that's why bila kita beli certain product, especially for lipids, because lipids ni dia punya quality issues. One is the changes in temperature will affect dia punya appearance, kan? Another one, of course, the rancidity lah. Itu memang quality issue number 1 dekat fat-based punya product, kan? Especially you're talking about food that use fat for yang fried food, kan? Fried food, okay, the more usage of the oil, you have to use a new oil, kan? Because of the changes, quality changes for oil, right? Okay. So fats that tend to crystallize in beta form. Okay. Examples: soya bean, olive, corn, cocoa butter and lard. So kalau kita tengok cocoa butter, okay, dia adalah in terms of beta form yang dalam coklat tu. Yesterday I mentioned about how some expensive chocolate, okay, nanti kalau pergi KLCC pergi try beli yang pakcik coklat tu if you haven't tasted it yet, okay. One of the most expensive is that brand lah, okay. Of course they have so many different brands overseas, maybe they sell it in Malaysia also, but that one is one of the famous one. Okay, nanti bezakan pakcik coklat dengan coklat berries. Bila you makan, you rasa macam mana? Tengok dia made kat mana, kan? You can actually compare. So the one that use a higher cocoa butter will have a more melting properties dari segi satiation lah bila you eat the chocolate, kan? So this cocoa butter is in the form of beta form crystal. Okay, so if we take this cocoa butter and look under microscope, you can see the beta punya packaging. Beta packaging tadi yang orthorhombic tadi kan? Okay. Yang dia macam packaging dia yang parallel to each other, yang two shape tu. One is this side, one is the other side. Okay. And then for the beta prime form, cottonseed, salmon, butterfat, milk fat, rapeseed, palm oil. Okay. These are all beta prime punya form. So if you take under microscope, so they are more stable lah. So that's why cakap palm oil is one of the best frying oil because dia more stable. Dia adalah one of the oil yang sangat stable lah dari segi smoking point dia. Okay. And then hydrogenation and esterification. This is processing action, okay, that can be used in a controlled manner. So bila kita nak buat proses hydrogenation and esterification, you have to control it, okay. Which esterified you are going to do, which double bond you are going to use, okay. So this is done to produce fat and oil with different melting and crystal habit to fit demands for a wide variety of food users. So kalau food manufacturer yang dia nak buat change, dia nak buat change in, because food normally you have to follow the demand of the consumer, kan. Macam coklat kita tak nak dia melt in the mouth. Sometimes ice cream pun sama, kan. The one that you want to is the one yang dia lambat cair, kan. So you have to actually control what properties in the food system in order to make it longer shelf life lah kita panggil, longer shelf life or longer quality. So in terms of oil, normally these are the major processing action or processing ways in order to change the properties of the fat. Okay, you can change the melting point, you can change the solid versus liquid or semi-solid by doing this hydrogenation and esterification. Dalam industri banyak guna yang ni, okay. Normally these are the one that is being used lah, hydrogenation and esterification, to change the fat punya properties, okay. Because they will change the melting point. So bila change melting point, it will affect the solid, semi-solid and liquid. And also it will change the crystal habit. Bila crystal habit ni, you play around with you can also have the melting point effect. You can also have the macam the taste, the grittiness, the smoothness, and also you can have the stability of the fat, alpha, beta, beta prime tu. Okay, so by doing that, you can fit the demand for a wide variety of food users. Okay, so these crystal structure are important. They affect physical chemical properties of fats and oil. So if it is alpha crystal, it partially coalesce alpha crystal and ice crystal surrounding air bubbles, forming network structure and texture of ice cream lah. This one kita tengok kalau dalam ice cream, because ice cream use a lot of macam whipping, kan, dia guna air. Ice cream tu actually it is actually a formation of air. Banyak air sebenarnya dalam ice cream tu. That's why it is more light. When you eat the ice cream, you can feel that when you eat it, okay, you have the taste of actually dia adalah air. Most of the ice cream, the component of ice cream is actually air. Sama macam white eggs lah. White eggs dia bila kita whip dia, kita use a lot of air kan. If you don't have oxygen or air dalam tu, it cannot be, dia tak jadi whipping cream lah. Okay. Beta crystal, a fine tiny needle crystal about 1 micron of size. Okay. So beta crystal ni will give the shiny surface of chocolate and confections. Okay. Will have smoothness, gloss in margarine and spread, and plasticity for margarine, shortening and baking fat. Plasticity ni, that means how easy for it to be spread lah. Okay. Of course kita nak, kalau margarine kita we want it to be more plasticized. Okay. Chains are perpendicular to each other. Okay, perpendicular tadi we have seen the structure. Can incorporate large amount of tiny bubbles in interstitial spaces. So dia akan ada spaces when it is packed, susunan kristal tu, dia akan boleh incorporate air bubbles dalam tu. Okay. And then for beta crystal, their clumps are responsible for grainy and sandy structure. This one is mostly larger crystal as compared to beta prime crystal. Is required for the flakiness of bakery shortening, for example, light. Okay. And then beta crystal, this one is the most contributor to the cocoa butter stability in chocolate. Okay. Nanti kita tengok apa isu chocolate tu kan. Okay. Bila kita makan chocolate, sometimes perasan tak ada this white spots ni kan. Kalau you perasan lah, sometimes especially if you go to Langkawi kan kita beli chocolate in Langkawi is cheap, but you have to see dia punya ni expiry date. Normally expiry date in chocolate, dia letak kat expiry date tu because there will be a time where you keep, and then duration of time where it started to form this white macam white surface. Dia bukan mold lah actually, dia bukan mold, dia actually we call it fat blooming. Ini white blooming. Then it looks like macam ada mold, tapi sebenarnya dia bukan mold. It's because of this crystallization of the fat in the chocolate. Ini memang isu paling besar dalam chocolate industry lah. Okay. So for beta prime crystal, cocoa butter replacer, or we call it CBR or CBS, can crystallize. So that's why kalau chocolate yang guna cocoa butter replacer, because I say cocoa butter ni is one of the most expensive butter in the world. So if you want to make the chocolate more affordable to consumer, you will use a lesser cocoa butter and replace with CBR and CBS. Okay, dia boleh pakai any kind of fat yang compatible with the chocolate, normally palm oil lah. So kita tengok nanti dalam kalau beli coklat yang mahal dengan coklat yang murah, bukan murah, yang affordable, you compare the list of ingredient tu. Nanti kalau pergi jalan KLCC ke pergi mana, I think KLCC have macam pavilion, I'm not sure they have or not, they should have lah, pavilion kan. Okay, so CBR, CBS, if you have that in the chocolate, dia boleh crystalline. Okay, it can crystalline upon simple cooling into beta crystal without tempering. Tempering ni, kalau nak tahu method tempering, kena pergi tengok dekat barrels. Okay, weekdays nanti you can go to barrels and you can watch from the glass wall tu. Okay, bila yang dia ada satu machine that they do macam dia mix chocolate tu, lama tau dia mix dalam tempering machine. I don't know how to say it. That one is called tempering of chocolate. So if you are like smaller scale industry, you kena beli, if you want to do chocolate business, you have to buy this tempering machine. Okay, dia akan kena chocolate or cocoa butter, dia memang nak tempering punya proses tu. Okay. Okay, if you want to see, you can go to the barrels and they can show you. Alright, and then beta crystal. So kalau chocolate yang use CBR and CBS to substitute the butter, okay, upon simple cooling, it will become the beta prime crystal ni lah. Okay, but for beta crystal, tempering is required to form the beta crystal. So that's why kalau for chocolate, normally you want to change it to a beta form, okay? In which is used for chocolate, cocoa butter and cocoa butter equivalent CBE. So you need this tempering machine. Tapi kalau for those yang manufacturer SME yang tak boleh afford to buy the tempering machine, normally they do manual tempering yang tak consistent. Okay. So you will have quality issues of the chocolate lah. Normally chocolate ini je lah selalu issue dia. Okay. So you see this one tempered, you will get a very nice glossy, hard, snap and doesn't really melt. Sebab dia dah tukar from this beta prime to beta crystal kan. We talk about how beta crystal is the most stable crystal form of fats kan, of lipid. Okay. So if you don't temper your chocolate, okay, so you will have produce indulge, straight crumble and melts easily. So kalau kita makan coklat tu senang melt, so kita tahu what is the reason. Most likely it is not tempered well. And what happens if it's not tempered well? It doesn't change to beta crystal. So dalam tu mostly, maybe, if you see under microscope, they are beta prime crystal. So belajar satu benda hari ni kan. Okay. So you see that especially in the chocolate, try to do the experiential learning, beli different type of chocolate, especially when you see the pure chocolate tu, they will use pure butter, cocoa butter as compared to the one yang guna cocoa butter substitute. And you can see the difference in terms of physical and also the taste varies because they use different composition of sugars and whatnot. But in terms of physical characteristics too, you can actually tell the difference, okay, because of that reason. So crystal in the solid phase, if you have class, you can leave by 12, 12:15, sorry. Okay, I will post this video in the Putra Blast and you can watch later. Okay, the crystal in the solid phase are not fixed but are able to slide from one another. So this is called plasticity. Plasticity is where one is how it can be spread and also how it can change from one crystal to another crystal. Okay, so the ability of fat to flow when external force is applied. Okay, the balance between two phases is critical. Too much crystal will have hard brittle fat with no plasticity, and too little crystal will produce fat which melts. Too little crystal. So this will limit. This will give a useful temperature range for each fat and designing shortening. Dalam fat industry ada banyak different types of fat kan. We have shortening, we have margarine, we have butter, we have oil. So this will actually give you have to, as a food producer, okay, if you work in a food production company, you will have to know about all these attributes now, how and why you can change from one to another, especially in fat industry, lipid industry. Okay, plasticity of fat depends on amount of crystal at given temperature, melting point of component triglyceride and polymorph form. Polymorph form ni is the crystal form lah. One is the amount, one is the melting point, one is the polymorph form of the component triglycerides too. Okay. So for plastic, it has many fatty acid, wide melting point range, and you can work. Dia ada wide range of plastic tu, meaning that temperature range dia is quite wide lah. Kita panggil plastic range tu. You can work between this high wide range of temperature, which is good as a food producer. Kita nak we want that at a wider temperature range, you can actually have the plasticity. Okay, for non-plastic, few fatty acid, few in number and similar length, very narrow melting point range. This one normally in food industry we don't want to have fat that has a non-plastic punya properties. Okay, stays hard and solid at temperature below melting point and melts fast when melting point is reached. Okay, dia ada very narrow dia punya range of the plasticity or melting point. Okay, if you change the temperature a little bit, then dia akan change the the properties. Okay, So all shortenings and solid fat are mixture of crystalline fraction. About 10 to 30% are dispersed in liquid fraction. So the proportion of solid to liquid that controls the texturization. For example, the stiffness, and the roundness of the solid to liquid. Okay, and perceived consistency. Macam mana dia nak become consistent in terms of solid to liquid, liquid to solid tu, that will control the texturization of that particular food or food system. Okay. So fat phase transition. Okay. If you want to learn more about this, okay, normally kalau for food tech student, we have one course that specialize in fats and oil only. Because we we study a lot of chemistry of food component lah. Okay. In your case, you study the technology, kan? You study technology, the engineering part of the food, right? But for food tech student, fats and oil, kita ada courses that is elective courses lah, we call it. Okay, elective courses. One of the elective courses that student normally take is this fats and oil chemistry. So when they study fats and oil, so this course will teach only the fats and oil punya properties, and part of it is to study the solid fat content. Solid fat content dalam fats and oil, in the fats and oil, you have different solid fat content. Actually, this one we normally bring student to MPOB in Bangi. Okay, they have the machines to actually measure the SFC or SFI, we call it, solid fat content or solid fat index of particular fat lah. So for pure triglyceride, pure triglycerides ni, the one that has yang 3 komponen triacylglycerol tu, yang 3 fatty acid. If it is pure triglyceride, the temperature range is very steep. So the sharp melting point, dia ada sharp melting point, narrow range, especially example of butter oil, butter yang change to oil lah, oil that is made from butter. Okay. But for fatty food, because dia a mix of system, when the fat has become food, okay, dia adalah a mix of many different triglycerides, many fatty acids, so dia jadi satu food system lah. So we call it fatty food, yang fat-based food. Okay, so you see that the fat-based food or fatty food, the SFC, if you take the content, you measure the SFC, solid fat content of the fatty food, dia ada wider range. You can see that the temperature from sini sampai sini. Actually, you can have a wider range. So ini yang normally for food system, we want the food to have a wider range of temperature that you can play around. Okay. In practice, solid fat content, the proportion of fat with glycerides will vary 10 to 30%. Okay, mixture of triglyceride, for example, lard, vegetable shortening, dia ada broad melting range and desirable plastic properties. So that's why dalam baking, kalau kita nak baking kan, normally lard ni of course is non-halal lah. Okay, but it is taken from, dia buat rendering of the fat from the swine, the fat from the swine, they render dulu, and then this one is used a lot in yang buat crust tu, macam pie crust kan, that one they use a lot, manufacturer use lard a lot, but for a halal setting, we use the vegetable shortening. Of course, one is the vegetable sauce, one is the animal sauce lah. Vegetable shortening will have almost the same properties as the lard in terms of making the pie crust punya crispiness and also the taste. But you know that also fat will contribute to the taste. Maksudnya the higher the fat, the better the taste will be kan. Okay, and then also depending on berapa percentage of the fat that is in the vegetable shortening versus lard lah. Some people yang they already used to use lard in making the pie crust tu or pie ni, they will not change to vegetable shortening. But in terms of halal and kosher, banyak yang tak boleh pakai lard lah. So most of food manufacturer will change to vegetable shortening. Okay. So when you have this mixture of triacid glycerol, then you can have a broader melting range and desirable plastic properties. Okay. Itu yang kita nak lah selalu for food industry. Okay, so melting point of the most stable polymorphic form of selected triacyl glycerol molecule. Okay, so ni dia punya susunan triacyl glycerol kan. Triacyl glycerol tu you have 3 triacyl glycerol, fatty acid lah. 3 fatty acid in the glycerol backbone tu. Okay, so dia ada satu backbone and then ada 3 fatty acid that will susun dekat dalam the molecule of TG or triacylglycerol or TAG. So L is the lauric acid 12O, M is the myristic acid 14O, tengok kat sini ya. P palmitic acid, stearic acid, LN is the linolenic acid. So you can actually see kalau dia packaging the TG tu semua yang LLL, so the melting point will be about 46. If it is MMM, so it will be higher. Tadi kita tengok kan, the higher the number of carbon chain, the higher melting point will be. Okay. Melting point of the AG depends on the chain length, the branching, the degree of saturation, of its constituent fatty acid. So maksudnya setiap fatty acid tu dia ada dia punya own degree of saturation and relative position along the glycerol molecule. This one also ada effect on the melting point. Okay. Nanti kita sambung lagi. Sorry ya, this one is the free. Semalam saya guna yang kawan saya punya account. Okay, we start again Okay, masuk balik link yang sama. Okay.